Can you guys hear me? Yes. Okay, maybe we get started as we have a busy schedule still for today. So first of all, very happy to see all of you here this morning. I hope every one of you had a great time yesterday at the dinner, at least I did. And yeah, I'm happy to chair the first keynote for today. I'm Henrik Tenkanen from Aalto University, Finland, and I'm happy to introduce Robin Lovelace, who is an associate professor of transport data science at the Leeds Institute for Transport Studies at the University of Leeds, and he's also the head of data science at the UK government agency Active Travel England. And in addition to these roles, I know Robin very well from the kind of open source software kind of community side. So Robin is super active person on developing kind of helpful tools for us to, for example, deal with mobility related things and so on. So I'm super happy to have you here. But yeah, without further ado, the floor is yours, Robin.
Thank you very much for the introduction, Henriki. And I would add that I've been maybe slightly less productive on open source software since the new role in Active Travel England. But I'm actually going to talk about open source software in this talk. As you can see, the title is Reproducible Research and Open Tools for Future-Proof Transport Planning. So when I was invited to do a talk, I wanted to think of a theme, and I'm happy that I didn't make it about AI. I'm very interested in sustainability, but I think there's a lot on that. And I think just this term, future-proof, everyone wants to build solutions that last a long time. And I think transport planning is a discipline that is actually about the future. A lot of transport infrastructure that you build is designed to last 10, 20, 30 years, even longer. And when we're talking about redesigning the transport system, we're really talking about the long-term future. So this talk is about thinking about the future, thinking about how what you're doing now can influence the future in the long term and hopefully have long-term beneficial impact. So what can you do now to have that long-term impact? And I think one of the things is actually talk to other people, network, get out of your silos. So Mobile Tartu is a really great example of that kind of collaborative thinking and people getting out of their comfort zones and having conversations, learning things from different disciplines, different people, different countries. So I've learned loads so far, both at the main conference part and the associated PhD school that preceded it. So Henriki has already introduced me, but I'm just going to say a few more words about myself, and then we're going to go into the main presentation. So in terms of introduction, as Henriki said, I mean, there's no particular order here, but I'm a researcher at ITS Leeds. I'm originally a geographer, but I really got into data science as a means to an end, so as a way to have impact. I've always been driven by this idea that research should have impacts outside of academia, and that has really been the kind of underlying driver of a lot of my research. So yeah, that's already been covered. I am the lead data scientist in Active Travel England, and that's been very interesting, seeing how data science, how to build new teams in government, and also how to bring in new approaches in government, and also seeing some of the limitations that civil servants are under. We really are very lucky in academia in terms of the amount of freedom that we have to innovate. And I just think it's great to see examples of close collaboration between academic sector and industry and government. And that's, again, a theme that I've seen repeatedly at this conference. Yeah, and I am a data scientist and have ended up doing some software development, which again, I'm going to talk about during this talk, not just software development in its own right, but software development as a means to gaining impact. So yeah, that's a summary of who I am. And just briefly in terms of those images, I'm the lead author of Geocomputation with R, and I I know some people at least have made use of that book, but just as a plug, it's got a chapter, I think chapter 12 is on transport, and I think that provides a nice introduction to working with origin destination data and visualizing it. And we also have a companion book, which is Geocomputation with Python, which is taking the same ideas and trying to provide a nice, easy way to get started with doing reproducible research. Okay, so in terms of what I'm going to talk about in this presentation, I'm actually going to start with some definitions, because I think a lot of these words like tool, model, open source get thrown around, but they're not really tied down, and people kind of assume that they know what they mean, and they assume that the person who's talking about these things means the same thing. But in my experience, there can be subtle differences between what people mean. So I'm actually going to start by defining the terms that I'm using to talk about open source tools and reproducible research. I'm going to talk about reproducible research and open tools with reference to some concrete examples. And then I'm just going to conclude with some comments on what I think we can do based on this information to make our work as reproducible as possible. I want to generate some debate. So as I said to Henrique, I definitely do not plan to spend the whole hour talking. So I think it would be great to have some questions at the end as well. So if you've got any questions, then I think this could be a good opportunity to talk about how we as a community can influence the direction of transport planning more broadly, and think about how we can direct our work for maximum future-proofness. So yeah, that's what I'm going to be talking about. So starting off with definitions, I've defined tool as a piece of software or an online service. So I like the metaphor of physical tools, and I think one of the speakers yesterday talks about a hammer as an AI tool. You found this new hammer and you want to use it. And I think that's really useful, but realistically, in the digital age, a tool is usually some kind of digital tool or online service. So that's a very broad definition. It's something that you can use, whether it's on your own computer through a command line system or it's an online tool. It doesn't matter. It's just something that you can use to get things done. A model is different, but usually there are models that underlie some of the tools. And it's a method or process that's expounded in methodological terms, and usually models underlie tools. And then software is the instructions. That's basically the cooking recipe that defines what the tool does. So they're all interlinked, but I think it's quite important to understand the distinction between those things. And then in terms of reproducible research, it should be obvious, but it means that other people can take your research. It's not you can read your paper, because I've actually heard some people talking about open publishing as if it's the same as open research, but it's very different. It means someone could read your work, follow the instructions in there, like download this data set, do these things, and actually regenerate your results. And I think that's quite a high bar. And I think the majority of research, the majority of transport research and research in general is not reproducible. And there are certain things that you have to do to make your work truly reproducible. Open source software is software that is free to use and modify. And an important thing, if you're looking at software, is if you try and find the license. So truly open source software has an open source license of some kind, an MIT license or a GPL. And again, there's some greenwashing in this space. You have companies saying, oh, we've got open solutions. And it tries to imply that they're doing open stuff. But if you look at the code, there isn't any code underlying it. So that's what we mean by open source software. And again, I'm surprised at how many times I speak to people who don't kind of realize the distinction. And then open access web tools is something that anyone can access without having to log into a portal. And I don't know how it is in Estonia and other countries, but in the UK, many of the tools that are provided by industry and by government, you need a login, and that creates a barrier to entry so that only experts can get it, and interested parties are kind of excluded. So that's what I mean by open access tools. Open access data, again, is slightly different, but gets conflated with this whole open term. and that just means data that is freely available to use. I believe open data should usually have a license, but the licensing of open data is, I think, less well-defined than open source software. And then finally, future-proof work that's likely to be useful in the medium-term future. What do I mean by medium-term future? Well, I think that's kind of up to you, but I'd say in 10 years from now, will you be able to go back and say, oh, that paper that I wrote or I thought of while I was in Mobile Tartu 2024, that still has some kind of identifiable impact on the world. And I think that's a really useful thing to think about, you know? If you're working on a paper, just put yourself in 10 years' time, what's going to have changed as a result of that paper? Are you going to have written a PDF that's hidden behind a paywall and then a few people read and everyone forgets about it? Or does it kind of continue as a legacy? Maybe it's being cited by other people, it's influenced other people, or it's resulted in some kind of change that is tangible. So those are my definitions. Sorry that was a bit long, but I think it's important to really tie down what we're talking about when we're using these words. So I'm just going to pick up on one of those definitions, and I think this is a good illustration. This is an early paper, and quite highly cited paper on reproducibility. And basically it shows that it's not a binary variable. Reproducibility is a continuum, and I think that's a nice way of thinking about it, because it's not like, oh, you're a reproducible person, you're good. You're not a reproducible person, you're bad. Everyone's on a journey, and I don't know anyone who has written 100% of their work as fully reproducible. That's a really high bar. As long as we're kind of moving in the right direction, then that's positive. And you can see there that, that on the spectrum, it's just a publication only, and there's no further information. You can provide the code, you can provide the code and data, and then you can link it to software and actually give instructions, give documentation of what you need to do to generate the results. That's the gold standard. And I think anywhere on that spectrum is good. Just publishing your code on GitHub, like many of the papers in this conference have done, is a really good start. But it's a journey, not a destination, I would say. So in terms of reproducible work, there's a question mark about, well, why would I bother? Maybe it takes more time to share the code. Maybe you don't think the code is a high enough standard. But that raises the question, well, why should you make your work reproducible? And there are many reasons for doing this. I just wanted to pick up this one bit of research by someone called RAF 2023, where they delved into, they were actually doing this paper in response to another paper that found that there wasn't a very big effect size of making your work open, making it open and reproducible. But then they tried to kind of split out, well, what do you actually mean by reproducibility? And they showed in quite a big analysis that having code that's available and reproducible, which are two different things, have an effect size. And as you would expect, the reproducible element has a slightly bigger effect size than code availability. And to me, that makes absolute sense. And I've seen it in my own work. If you make your code available, someone's more likely to use it, and then maybe that they're not going to copy it, but it can influence their own work, it can speed up their work and allow them to do more things. And as a kind of thank you or reference to that, they cite the paper. So that's like a kind of personal motivation for making your work more reproducible. A more kind of broader reason is it encourages scientific rigor. One of the main founding principles of science is falsifiability. And if your work cannot be reproduced, it cannot be falsified. So if you want to be scientific, reproducibility is really important. It's got benefits for your future self. So even within a single paper, you might get it to a certain point, send it for peer review, and then it will come back in 3 months, 5 months, if you're lucky, hopefully not 12 months, as has happened to me sometimes. And you might have forgotten everything that you did, but if you've got a reproducible repository with all the code, you can easily modify things when reviewer 2 says, oh, I want you to make all these changes to the figures. So it's actually a benefit to your future self. Benefit to others, I think that's kind of obvious. If you put your work out there, you can actually save people time. Like, that's a big motivation for me. I see a lot of people, especially PhD students, getting started with data science, and they spend hours and hours cleaning data. And if I've already gone through that painful process and come out the other side alive, then I want to share the benefits with them so that they can get on with the more interesting stuff. So for me, that's a really big motivation. And as is hopefully demonstrated in this research, and this is actually an ongoing area of research, like the impacts of reproducibility, I think, as I'm going to talk about more in this talk, if you make your work reproducible, it does have a potentially huge increase in the potential for impact. So if you do a study on Tartu and you write all the code, that could influence Tartu City Council, it could change decisions. But if you make a really good reproducible repository and the method is good, it could be replicated in 10, 100 cities and have a 10, 100x increase in the impact of that work. So that's, for me, a really big motivation for making your work more reproducible. Okay, so if you're not persuaded already to do this, let's just try and take the counter argument. So thinking of someone who's playing devil's advocate of like, why would I bother? There's also a whole load of reasons why not to do that. And this is a hierarchy, and this is arranged in terms of what I think is more plausible to the least plausible arguments, but I've heard all of them. So one is time, and yeah, especially if it's the first time that you've done a fully reproducible paper, it will take a bit more time to get a GitHub account or a GitLab account, wherever you want to host it. You have to think carefully about what the steps are, you have to provide documentation, and when you just want to move on to the next paper, that may not be number one priority. So I think that is a legitimate reason. Know-how, I think, is a really good one. I mean, talking about GitHub and stuff like that, that's kind of the domain of software engineering. And none of us have been trained in software engineering. I didn't do a degree in computer science, and all of us are kind of having to learn as we go along. But I think that know-how is available everywhere, and you can go online and skill up. And I think that from what I've seen of the practical sessions with the PhD school here, there's been a lot of knowledge sharing, and there's always someone that you can ask for that know-how. Lack of permission, I think that's a very legitimate reason in many settings. So if you work for a organization that doesn't have an open culture, they can actually prevent you from publishing your work. And I've seen that both in government and especially in industry. The majority of people doing good stuff in industry actually cannot publish their work because they've got, in their contract, they can't do that. And that, I think, is a legitimate reason that's a difficult one to address, and there are ways around it that I won't go into in this talk. The software's not open. You're using Stata. I think you can still publish some of the code, even if the software itself isn't open. The data's not open access. I think that's a really interesting one, especially for people using mobile telephone data. And there is a good solution to that, which is to create synthetic data. So you can't share the particular data set that you've got, but if you're good at data science and you are committed to reproducibility, there's no reason for you not to create a data set that has the same content, like the same column names and the same structure as the data that you have, but the values are totally randomized. And I think for many people, that will be the single biggest way to improve the reproducibility of your work. So you can provide the code, the data is hidden because it's proprietary, but if you just take that time to create a synthetic data set that allows someone else to run the code, that's a really big benefit. And then someone might use it in unethical ways. I've heard that of my own research. Like, oh, what if someone takes your code on prioritizing cycle infrastructure and uses it to build roads? Wouldn't that be terrible? And I mean, yeah, but also I think the argument that people could take that work and use it to prioritize walking infrastructure is equally valid. So I don't think that's a particularly strong argument. And then the final one is someone might steal the work. And I think there's some, I think for academics, that fear of being plagiarized is a real concern, especially if you are if you're just getting started in academia, you've got a lot of ideas, putting it all out there in the open straight away can be a bit of a risky strategy. But from what I've seen, in some ways it can actually protect you, because I've heard of instances where people have had ideas for a long time, they present it at a talk, and then someone else takes that idea. Imagine if that researcher had put it on GitHub, it was all documented, you'd have like a kind of trail of evidence that leads back to it. So I think that one is not as strong as some people think. So there's a whole load of reasons why not to make your research reproducible, but I thought it's worth addressing them up front. So I've got an example of what I think is a fully reproducible paper, and people can try and reproduce the results if they want. So this was published in JOSIS, and it's about generating a zoning system that's very broad, like you can use it for different things, for visualization. And we actually wrote the paper as documentation in a package. So the paper was initially written as a vignette in an R package, so it had to run, otherwise the tests in the R package would fail. And I'm using this example because I think it links nicely. It's a good example of how reproducibility is more than simply the act of reproducing the results. It also links to a broader idea of generalizability. And if you can reproduce your work, it's likely that you can generalize it. So we didn't just develop this system for one place. The idea is that you can use this zoning system in many different contexts. So we've got an example here for London, which I think hopefully shows the benefits of providing a standardized zoning system. So the idea is you've got geographic phenomena, can be very complicated, and they can change very quickly at multiple different geographic scales. And therefore, when you provide a zoning system, you are subject to the modifiable area unit problem, which I imagine most people know. Can people put their hands up if they've come across the modifiable area unit problem? Yeah, so if you just use what you're given by the authorities, the results will be influenced by that. If you have a standardized zoning system, that can help, especially if you want to compare different cities that are likely to have different zoning systems. And so we use this approach to try and look at one thing, which is road traffic casualties in multiple different cities. And hopefully, this shows the benefit of having a standardized zoning system. So, as I say, the fact that it's reproducible and we can demonstrate that it works for multiple cities should enable other people to use it for different purposes in different places. And again, something that's quite interesting as well is talking about the importance of big cities. And I've heard multiple times, oh, London is way bigger than Paris. But if you look at a standard grid system, you can see that with Paris, it's simply that it's got a smaller definition of the boundary, and they're kind of similar in terms of the wider area. So it gives a standardized way of thinking about cities without reference to more or less arbitrary spatial constructs that are the administrative boundaries. So that's an example of what I think is a fully reproducible paper. I think another step in the direction towards open science for impact is taking your idea and turning it into some kind of tool for impact. So that's what I'm going to talk about here. And a case study that was actually partly influenced by conversations in the summer school, and credit to Egor, who's working on this data and presented on it yesterday. It's a data set that's made available by the Spanish Ministry of Transport. And like many government data sets, like it's kind of hard to use and it's a bit tricky to understand. So while Henrique was doing his session on using data from Helsinki, I was in conversation with Egor, just kind of revisiting this data set that I tried and failed to make sense of a year or so previously. And I'm happy to say that thanks to Egor's work, I've managed to make some impact here. So just as an illustration of what I think the benefit of this could be in terms of time saving, this is quite a simple example, but on the left-hand side, you've got some lines of code, and you don't need to worry about what's in there. Those lines of code go away to the internet, they download this data set, and then they convert it into an analysis-ready format. On the right-hand side, and that takes 9 lines of code, on the right-hand side, the first 2 lines of code do exactly the same thing, basically. Not only that, they do it for 7 days, whereas on the left-hand side, the before, you'd have to write that same block of code 7 times. So it's a way of saving time. It's basically automation. And I think that concept of saving time, automation, underlies a lot of software. If a tool doesn't save you time, what's the point of it? And I think it's useful to refer back to the concept of a tool that is not in a digital form. It's like the physical tool, like a tool, like a saw or a hammer. You want to use it to solve a problem. And I think that's a really useful way of thinking about software. And it allows you access to things and do things that you wouldn't be able to do otherwise. So yeah, this, by the way, is an R package that is like in prototype stage. I don't think it's fully production ready, but if anyone wants to use some of this data, we'd be very interested to hear some feedback. And another feature of open tools is because everything's open, they tend to be very modular and they can be used interchangeably. So once you get your data into this format, it could be R or Python or another language like Julia, suddenly you've got access to a huge range of other open tools that you can use. So in this case, instead of developing our own visualization stuff, we've just used an existing package to try and make sense of it. So you can go through the pipeline and then write this reproducible data analysis code, which groups the OD data by the origin, by the destination, and it simply counts the total number of trips. And then, because this is a massive data set, we've filtered it to only include trips with more than, OD pairs with more than 500 trips. The collect one is a important function there because that takes it out of the database and puts it into memory. And then we're using another package that you can't really see there on line 10. That's using a package called OD, which takes origin destination data and it links it to geographic zones to create the geographic desire lines that are shown there. And then we're using another package to create this quite simple visualization. As you can see, it kind of looks like Spain. There's some weird big lines, and I was skeptical that that was real data. But in fact, it may be airline flights. So the data set includes zones in France, and it also includes zones in the wider territories in Spain. So potentially that's an airline flight, but I don't know for sure. And I'd be very interested to speak to anyone. If anyone from NOMON is still here, NOMON, then we could have a conversation about that. But anyway, I think it's a useful case study. And without going too much into the detail, I did one more thing. Like, I always want to understand the data set. Like, when you're looking at a national data set, it's almost too big to understand what's going on. And so I decided to take a case study city, which was Salamanca, which is actually where I did my Erasmus studies. So I know the local context a little bit, and it's super useful to actually see what the zoning system looks like. And I think I was a bit disappointed when I saw this, because you can see some of the zones are pretty massive, and they've also got a weird shape. Like, I find it strange that the grey zone there has another zone inside it. So if you're just taking the centroids of each zone, then that's going to be problematic. So based on that, and this provides another example to show how you can use tools that were developed for a purpose, for multiple different purposes. Obviously, a standard thing to do would be to visualize the origin destination data in that city. And yeah, that looks good. But if you're doing mobility research, and if you're interested in active modes, that's really not good enough. Like, those points are really far apart. And if you were to build a cycle network from that, it wouldn't be very good, because you would only include the centroids. So another thing that I did, just to take this example a bit further to illustrate the concept, is to do origin destination disaggregation. And again, this is based on open source software called OD Jitter, which is written in Rust, so it's fairly high performance. We've got an R interface to it, but we're interested in creating a Python interface to it. And what that does is it takes that data and then it subsamples for the biggest desire lines based on some disaggregation threshold, it creates more desire lines. So in this case, I think I set the disaggregation threshold to 1,000, which is still a very high number. But if you wanted even more detail, you could reduce that further. And that just spews out many OD pairs. And the origins and destinations are randomly distributed to subpoints within each zone of origin and destination. And that's a useful process, especially if you're working on active modes like walking and cycling, because you need the short distance trips. And when you've got quite low resolution zonal data like this, the problem is that the majority of trips in a big zone will be from that zone into the same zone. So it's intrazonal flows. And what jittering can do is it can kind of take that information and allocate the flows within the zones. Obviously, the results aren't going to be perfect, but we've done tests, and there's a paper that shows that the resulting flows, once you put that through a routing engine, are way better after you've done this jittering stage than if you haven't. So again, that's an open source tool that was fairly recently developed for a specific project that I think could be useful for multiple other projects and adds value to existing data sets. And I think I've explained the method, but just briefly, and this is a slight detour in terms of how the method works. This is a visual description of it, and there's a paper associated, which is an open and reproducible paper. You have OD data, like was shown in the previous slide, and then there's two stages. So one of the stage is to slightly randomize the origins and destinations. So instead of just using the centroid or the population-weighted centroid, why do we just take that arbitrary place in space? It could be anywhere in that zone that the trips are starting and ending. We just move it slightly. So in figure B here, the start and endpoints are just simple random allocation, and they've just shifted slightly to a random location. I think that's probably not the best. That's not going to give you the optimal. But if you can imagine multiple OD pairs originating in a particular zone, it will still give you something more diverse because you'll still have multiple starting points, and it'll give you a much denser network. The next stage in figure C is, rather than just picking a random point in space, you kind of constrain the subpoints to something. And in this case, we've used the road network and vertices on the road network to do that. But you could use anything. So let's say you're interested in mobility for elderly people. You could use their specific trip attractors as the subpoints. And we've used this for travel to school and other things. So it's a very flexible approach. And then the final stage is, by setting this disaggregation threshold, you can kind of break up the lines into multiple lines. And because you've got multiple subpoints in the origin zone and the destination zone, you can do OD data disaggregation. So that's an example of an open tool that we're using. And I think it has potential to be used in other things. So if you want to see it, that's the GitHub repo. The lead developer of it is Dustin Carlino. And I think many people here are working with origin destination data. And I was joking yesterday that if this conference was called the OD Data Conference, I think it would be much better known, because it was called Mobile Tartu. I never knew that there was so much kind of mobility and OD data in here. Okay, so that's an example of an open tool. But again, it's still not in production. You could do an amazing piece of work, add value to the data, and then again, it just sits on your computer, or you do a project. So the next thing that I want to talk about is how to go from your open source software into open access so that people can actually use it. And talking about impact, it's obvious, but if no one can use your work, then there's no way for them to be influenced by it. So we've got this definition of open access here, which was actually developed first in the field of GIS, and it goes beyond open source in that it gives everyday people who are not software developers, who are not data scientists, who are not specialists, the option to use that. And the final part of that quote talks about making a user-friendly interface and actually building a community of people who are using this tool. And I think that's the hard bit, because that involves much more than the technical question. You have to do workshops, you have to build relationships with policy, and you have to get it into practice. And that is a socio-technical process, I think. And I've got the most recent example that I'm working on is the network planning tool for Scotland. So that's funded by the Scottish government and being developed in collaboration with the charity Sustrans. And we have this web tool. You can use it as a web application, and we want to make it as user-friendly as possible. And if you want to test out the development version, I've got the web link there, which is mptscot.github.io. And we're really trying to make this as usable as possible. So that's some of the stuff that I've been doing. I'm going to say a few things about stuff that other people are doing that I think actually helps address one of the critiques of this approach. So data science, I think, is very much a top-down process where the, quote, experts take data, which may not be representative data, they put it into a map, they tell a story, they make a nice visualization, and then they tell everyone to use it. And one of the problems with that, it can be quite disempowering for other people, like the public and transport planners, because where do they fit in? What do they get to do? They just get to look at your visualizations and be influenced by them, which I think is a good thing. It's much better to have a detailed evidence base to work on than nothing. And in fact, the network planning tool and other tools like it, some of the biggest users don't end up being the target audience of professional transport planners. They actually end up being the advocacy groups, potentially for travel to school, like school headmasters, even parents can use these tools. But there's not much you can do other than looking at it. So what I want to think about is how we can move from just providing tools that are descriptive to tools that are actually two-way. And one example of this is from the ODNet project, which is an open source tool and is pretty amazing. It's available at od2net.org. What this does is it allows you to pick a place anywhere on the planet, zoom in, and then it automatically downloads some OSM data, and then it allows you to play around with routing profiles. And it will do that all within your browser, so you don't need to download any software. It just kind of works. And as you can see there, it gives you, in this case, a three-dimensional space where you can make the routing profile more focused on green space, more focused on level of traffic stress, or more focused on amenities. And because this is all open, you can adapt that in any way that you want. So that's, I would say, fairly in development. And I have tried to use this on a project, and I would say it's not super easy. It's written in Rust, so if you know any computer scientists who are interested in getting stuck into a code base that has like WebAssembly and all these exciting technologies, feel free to point them in this direction, because I think it's very interesting. But I don't know how to use this on a production project at the moment, but I'm very excited by the possibilities. So another example, and apologies for the quality of the GIF here, because I had issues recording it. This shows going even to the next step of interactiveness. You can actually play being a transport planner, and this is something that I've been involved in Active Travel England. So this is something that was developed in Active Travel England to support our work in government, and the aim is to provide a tool to make the digital tools that we have two-way. So the idea is that local authorities, rather than just sending us their data in a PDF or in a questionnaire, which they do, we give them a data collection tool that we use to gain valuable information about their plans. So we need to know how the money that we're spending or that we're giving to local authorities is being spent. And this tool, which is called the Scheme Sketcher within the ATIP, the wider ATIP platform, allows anyone to play Transport Planner and rapidly sketch interventions. So the example that's shown there just shows how you can sketch a polygon, and it's quite cool because it's a polygon that snaps to the road network, so that can save a bit of time. And then you can output the JSON and share that JSON with other people or share it with us. So it makes the whole process much more participatory. Again, this is fully open. This is hosted on the GitHub organization, github.com acteng, so ACT being Active Travel England and ENG being England. And I think that's potentially a bit of a game changer in terms of collecting data on plans. So you're not just collecting data on what's currently there, you're collecting systematically data on the forward plan of every local authority in a country. And I'm not sure, but to the best of my knowledge, I think England is the first country where we're using this kind of GIS approach to collect a systematic data set. And again, it's open, so instead of building your own, you can build on this or use the ideas in it for other stuff. So with all of that in mind, and moving on to the final part, and with a head nod to Yuka, who also had an AI-generated image in there, how does all this fit into the future? What does this mean when we're thinking about the long-term future? And initially, in the first draft of these slides, I actually had quite a few slides on AI, but I decided to put those in an appendix and just focus on what we can do at the moment. I think that's a much higher level discussion, and there's been a lot on AI, so I'm actually going to focus on like the here and now and things that we can actually do right now. And just starting off by saying that being open to change and realizing that political priorities and the things that are important right now may not be important in the future. And the same does actually apply to AI. Is it just a fad? Who knows? But I think we can start with a positive there, that there has already been a massive shift away from the focus on cars to sustainable transport. So being adaptable to those drivers of change. So that's the kind of high-level driver. In terms of what we can actually do as researchers, I think sometimes people are too focused on the high-level stuff and actually to the detriment of the concrete steps that you can take. So I've tried to make this much more kind of focused on the here and now. So this is actually based on a debate that we had in the TRA conference in Dublin earlier this year. And just think of it as a hierarchy. So number one, if your publications aren't available, then it's very hard for them to have impact. Number two, making open access to the data, or at least linking to the source of the data and generating synthetic data if it's sensitive, making the code accessible. Stage 4, which is, I think, where it starts to become more time-consuming, fully reproducible paper published with documentation. That's like the gold standard in terms of reproducibility. And then 5, which can be a whole research project in its own right, is actually deploying that tool. So I think thinking about it in those 5 steps is a useful thing. And then you've got a parallel set of considerations around collaboration, which I'm not going to talk about, but you have a parallel system which is linked in terms of how collaborative is your work. And there's a paper on this by Braga et al., which I recommend on that. So yeah, final thought that I've got, similar to how we thought about why wouldn't you make your work reproducible, let's just pose the opposite question of what happens if you don't use open tools. And I think it's fairly clear that the direction of travel is towards more openness. And in climate science, there's this concept of stranded assets. If we do decarbonize, suddenly you're going to have hundreds of millions of pounds of assets that are that suddenly become worthless. And if you just think about if this trend to openness continues, if you are someone who is using primarily proprietary tools, could you end up being like some of these people in the fossil fuel supply chain and just putting all this investment into something that isn't future-proof? So that is the final slide of my talk. I've got the conclusions there, but rather than read through them, you can see them. I think I'd like to end it there and actually open up to questions, because there's loads of ideas and loads of people who can contribute back and talk about this. So let's make it more of a conversation, not a lecture. So many thanks for listening anyway, and thank you to everyone for making this conference happen.
Thank you, Robin, for a very, very inspiring talk. Do we have any questions for Robin? Yeah, there, Jukka.
Thanks, Robin. Excellent, excellent keynote, and yeah, touching my heart. Very inspiring. And yes, reproducibility is the thing. And well, I mentioned, what about this horrible word, irreproducibility? And I mentioned, and AI will hit us with this. Do you agree?
I do. And in fact, so I don't know if I've got a slide on it, but I do think that AI, if you use AI in your pipeline, it can have negative impacts for reproducibility. Yes. It is a black box. It's one of the reasons why AI can be more irreproducible is that it requires quite expensive hardware. Like, I may have access to a GPU, but a first-year PhD student may not be able to afford this massive, expensive computer. So I fully agree AI can have negative consequences for reproducibility.
Good. Any other questions? Yeah, there in the back. Oh. Okay. So there first and then.
Yeah, okay. Sorry for the one who was waving. I was waving as well, but in any case. So thanks, Robin, for super fantastic talk and really important theme to be always discussing, I think. One of the things that I was thinking in the communication on reproducibility, so somehow I didn't hear you using the word transparency. Of the work. And I think that that's one of the things which is quite sort of important in terms of justifying why we have to do it. So even in the cases where, as you were saying, that we need to be using a tool only if it's faster or only if it saves time. So sometimes we should be using it even if it's faster, so even if it's not faster, so just to be sort of bringing quality through transparency. And I think that somehow communicating that as well is useful as well, or also for example, students who might be sort of scared of producing something that really is reproducible, or something that others could be running, for example, as such. But just to be sort of not scared, but rather okay in sharing what you have from transparency perspective is useful. But then a question to you, so how do you see the future, not only in terms of AI, but also in terms of data? Because I think it has been going not to the more open direction, but rather to the more closed direction, at least in the field of mobility studies and transportation studies.
Great questions. So first, on your point about transparency, I really like this, and because one of the problems with communication is that we as academics, we can have all of these detailed discussions, but when you speak to someone in the street or in the pub, they're like, what are you talking about reproducibility? So transparency seems to be a much more easy to understand concept. So I think yes, and that's definitely something that I agree with. So yeah, transparency is something that everyone can kind of understand in terms of we can see that the processes that led to it. In terms of the trend in data, I think it's becoming much more managed, and the ecosystem of data providers is consolidating. I think there are risks and benefits in there. So I'd say I think it's becoming less common just to dump your data somewhere for everyone to have a free-for-all, and more common to make your data available through an API. And if there's more data that becomes available through APIs in a controlled way, I think the overall impact could be beneficial. But I take your point that in some areas it is becoming harder to access data, and like it's not my area of expertise, but yeah, I agree that there's a risk there that there's less and less open data as time goes by.
Yeah, and then we had there a question.
Thanks for the talk, Niehua from TU Munich, and I'm also the member of the Open Modeling Foundation, and recently that we just also submit a paper that for this kind of the good enough reproducibility. So it's a very important topic, but like when we are drafting that paper, that we do have a really also a large debate and discussion about this. Currently that we have faced lots of different issues about this reproducibility problem around the whole world, but every different regions, they might have their own culture or tradition, like in this kind of the reproduced research. And when we are trying to creating those kind of the guidelines for the early career research scholars, we also having the debating about that, should we like creating some very local guidelines, maybe they can match more and very practical, or should we create a very like unified guideline could use like globally, then every early career researcher, they can refer to it and use it. So I wonder that from your perspective, do you think which one may be more practical? Should we use a practical, unified one, but also globally, or should we matching more to the local traditions or cultures than like based on what they need for their own? Yeah, thank you.
Thanks for the question. I'd say both. I think it's useful. I think one of the great things about academic research overall is it brings together communities from different parts of the planet into the same space. So I'm in favor of another word, de-siloization, so not having things in boxes. So I think having frameworks that work anywhere is good, but also you can have kind of local implementations of them that can maybe put things in a language that makes sense in local context. So I'd say do both, and hopefully this like some of the ideas in here could be useful. One thing that I do know as well is that there is a plan in the head of Frank Wilcox, I think, to do a special edition, a special issue on reproducible transport research. And to be honest, I think transport has been slow. There's been a few papers on the topic, but there hasn't been like a concerted focus on it. So I think, what you're saying, it really feeds into that. And I think now's a good time for the transport community outside of this room as well to really think about, as a discipline, how are we on that continuum of reproducibility? And I think we could do a lot better.
Yeah, we have one question in chat, and I actually had very similar question myself. So yesterday we discussed quite a bit about like generative AI and so on. So I was wondering, like, how is your view? So could we maybe in a few years kind of use some of these generative AI kind of approaches that, okay, if we have like a repository, put the generative AI there that could actually help us like speed up the process of creating these reproducible processes, because it is a lot of work documenting everything, and I think these new tools could actually help us out quite a bit with these.
Absolutely, and I think that's a really good point, whoever made it, because it is a pain, or it was a pain. It was even more of a pain. Like, go back to 2010, 2011, when I started writing code, there was basically nothing. GitHub was just in its infancy, and to get feedback on something, I would email someone and they would send me an R script, and I would try and figure out how on earth do I reproduce this random bit of code that someone sent me. Now we're in a totally different era, and I think it's good to demystify AI. People talk about AI as if it's this magic thing. If you think about it more prosaically as like something that can help you get jobs done, then yes, that's very useful. And for me, already, I am using GitHub Copilot to help with the more boring parts of reproducibility. So if you're writing some code, you can focus on the exciting, interesting, impactful stuff, and then the AI can be kind of auto-generating the boring for loops and remembering all the function names. So I think there is potential, and as was discussed yesterday, AI, there's no way to stop it being used at a society level. That like this generative AI is here, and it's more like can it be useful? And if we are going to use it, let's use it in a way that we control. So specifically, VS Code with GitHub Copilot allows you to write code in a way where the AI is like trying to do auto suggestions constantly, and you're in total control over which one of those you want to accept. So when I'm writing code, it's maybe like 30% of the suggestions I accept, and the rest I'm just writing my own code. So I think that's a really good point. It is going to go towards more automation in the future. So there's tools like there's Open Devin and a project called Devin, which is seeking to like go a step beyond this and like actually set up the repo for you and start interacting. And I think that again has the potential to help in this space. There's probably also risks there, but the stuff that I've seen and that I use is beneficial in this space.
Oh, very interesting.
I don't know if that answered your question as well, Henry.
Very well. Okay, yeah, there, of course.
Thanks for a great talk, Robin. I wanted to come back to the question of open access data, and you made the point that oftentimes when you work with proprietary stuff, it's really difficult to publish the data because the original sources don't allow, and therefore a certain degree of synthicity or like a synthetic copy of the data could be a workaround towards that. I want to ask you to elaborate a little bit on that, because in one way, a synthetic data can be set up to, of course, reproduce exactly your result, but the whole kind of point of falsification is to see if you made wrong assumptions in the data. And if you have a synthetic data set, it seems to me it would be very difficult oftentimes to set it up in a way where you can truly test the assumptions of the model rather than sort of by definition reproduce exactly what you want it to reproduce. So I'm a big fan of, for instance, synthetic population data sets and really great sandboxes for highly granular, detailed modeling data. But when it comes to sort of a travel survey result, you can't publicize the raw travel survey data, which is under protection. What are your thoughts on that?
So I'll turn it around to a follow-up question for you. So let's say you've got a research project that uses a non-open data set, and then you've got the code and you want to show that it's reproducible. Do you think the fact that you cannot reproduce all the results in their entirety is a strong enough reason not to create a synthetic minimal data set? Like, I think in this synthetic data idea, I'm not talking about generating big synthetic data sets. I'm just saying a minimal example to prove that the code runs, not to get the same result. So I think, do you think, to put it back as a question to you, do you think the benefits of proving that your code runs and it generates a result, and you can say in the appendix, if it's like a technical appendix, you won't get the same result because this is a minimal data set, does that invalidate the whole benefit of reproducibility? Because I think my view is that it proves that you get something, and it proves that you have an input and an output, and the output won't be the full result, but it proves that you've got code that's running there.
Yeah, I fully agree that for proving that the code runs, that works fine. But oftentimes with the sort of statistical analysis, the question is, did you specify everything? Like, did you slice the data right? Did you use the right assumptions? And therefore, the kind of that part of the statistical analysis, I think, from synthetic data is much more harder to validate.
Agree. And I think there's, I think I'm getting at the wider point is that if you over-rely on synthetic data, then you can end up going in a direction towards Gen AI without having the kind of human in the loop. And there's a danger that we train these models on quite a limited and biased sample of human data that we've got access to, use that to generate 10x more data, and then do all our analysis on the generated data, ignoring the importance of the original data. So I think in that case, like, I don't think synthetic data should be used in that way. I think what I'm advocating is minimal data sets to show that the code runs, not that you get the same results.
Okay, thank you. Unfortunately, I need to stop you there as we are running out of time. But let's give one more time a big applause to Robin. And as is the tradition, here's some greetings from the organizers. So I believe this is the 30-day map challenge book, or? Yes.
Wow.
Yeah. And then some. Yeah.
So good.
Something to eat. So.
Okay, thank you so
Yeah,
much.
thanks. Good.